Hi chat. So, the big balls game, even though there really isn't any balls. Leave me alone.
in the ground and he's just going to slide off, and that's without restraining his rotation. So if we now select the player and double click on our player movement script. On this line, we're adding a forward force of 2000 and then of course multiplied with time.delta time. However, it would be really neat if we were able to modify this value in the inspector instead of just hard coding this into the line. To do that, we use variables. In C# I like to think of variables like containers. Just like you can store items in a box, you can store data in a variable. In the beginning, we focus on storing symbol values like numbers or text, but variables can be used to store way more complicated data. Each variable is given a name. This pretty much just means slapping a label on the container so that each time we use that name it refers to the data of the variable. We also have to specify what type of data we want to store. For starters, you should learn and memorize the 4 fundamental data types. Integer, we just write int. This stores a whole number. It can also be negative. Float, this stores a number with decimals. String, this stores a piece of text. And boolean, we just write bool, and this is the simplest of all the data types because it can only have 2 values, true or false. So creating a variable looks like this. Unity also allows us to edit a variable in the inspector. To do that, we mark it as public.
Okay, perfect. So, wait, he said something important. I'll rewind later, but public int health. So int, we just learned that that's numbers. So basically, since health is a value, an amount of numbers, it could be from 1 to 100, 1 to 10, 1 from 1000 even, but it's still a string of numbers. It's not the other thing, which was decimals, because there's no decimals in health. There could be, but there isn't, because there isn't, bro. There just isn't, except, but like, yeah. See, because I'm very smart. Very big brain.
Vector. To do that, we mark it as public. However, this variable is currently on. Unity also allows us to edit a variable in the inspector. To do that, we mark it as public.
That's what public is. Public is when you can edit something in the inspector. So in the inspector, it'll say like health, and then you have to type a int, a number. Big brain moves right there. Big brain moves right there, bro.
However, this variable is currently unassigned. It has no value. We can assign the variable a default value by simply typing equals and then the value. To get the value of the variable in code, we simply write its name. Like here where we are printing the value 10 to the console. We can of course also edit the value of a variable. Here we set it equal to 5, and here we add 1 onto the current value, making it 6. So if we want to turn this number into a variable that we can edit in the inspector, we'll go up here and create some space. We'll write public, float because we want a number that we can fine tune with decimal places. Then
yeah, float. That's the decimal thing. You can tune it with the decimals. So if we want this number here to be edited with decimals, then we're gonna do public float. Yeah, so float. Int is numbers, float is numbers with decimals, bool is true or false, and string is text. Perfect.
Need a name. In our case, we could do something like forward force, and we can set a default.
Oh, public float. Oh, okay, perfect. And then forward force. Oh yeah, this is gonna be the thing that's gonna say in the inspector. So it's gonna say forward force, and you can set the value to a number with a decimal, or just a number if you like.
Value. In our case, we'll just set that to the same 2000. Then we can substitute
2000 F. F is weird. I don't know why there's F there. But yeah, semicolon, save.
to this number with forward force. So we'll just take the forward force here and paste it down there.
Oh, okay, yeah. Yeah, so whatever this forward force is set as, so in the inspector it's going to say forward force. Default will be 2000, but then you can change this. And if we write forward force here, the Z axis is just going to be the amount of force, which is the forward force that we typed in the inspector.
If we now save, go back into Unity, we can see that we are now able to adjust the forward
Yes,
force
and the
in
default is 2000. Bro, I'm so Sigma, bro. I'm so big brain. I'm so big brain. And then we can change this right here. Absolute cinema.
Inspector. We could set it to 4000 or to 1000. If you click and drag on it, you can even fine tune like this. And you can even edit it while playing. So now of course we need to change this comment here. Instead we'll change it to something like add a forward force. And it's time to have a look at doing some player input. Now the fundamental thing to understand when doing player input is the if statement. If you make some room beneath our add force method here, we can write if, open and close a parenthesis, and then open and close some curly brackets. This is the
Calm down, buddy. Calm down, buddy. You're going too fast, little buddy. But brackets, curly brackets, that's
basic structure of an if statement. If statements allow you to only execute code if a certain condition is met. This is where you put your code, and inside of these two parentheses is where you put your condition. Sometimes it's really simple, say comparing two numbers. We could write if 3 is bigger than 2. Of course this is always going to be true, and so this will always be called. We can also say if 3 is equal to 2, and this is of course false, so this code will not be called. We can also write other stuff, say if 1 is equal to 2 minus 1, and this is of course true, or we could put not equal to, and now it's false. But this is only the stuff we can do with numbers. We can also put other stuff in here. If we want to check if the user is pressing a certain key on the keyboard, we'll go input.getKey, and here we'll also open and close a parenthesis, and in here, in quotation marks, we write the key we want. So in our case, we want D to go to the right, and now everything we put inside of these two curly brackets is only called when the user presses D. So we could of course just go ahead and add some more force.
Okay. Yeah, I don't think there's much for me to explain here. It's very simple. The guy explained it really well already. But the reason I'm also explaining these is because, just as a recap for myself, so I don't forget, like, like last tutorial. But yeah, perfect. So if input, so there has to be, if there's input, I guess there has to be spaces between the brackets. That I didn't know. Input dot get key. So input, I guess, dot get key. So you get the key bind, and then you write D. So when you press D, if the get key D, if the key D is being pressed, then do this.
Forces here. Let's say rb.add force, and in this case we don't want to add a force on the z-axis, we want to do it on...
Oh, perfect. I'm so smart. Alright, so rb.add force. So it's going to add force, but not forwards this time. And since D, we will be using WASD as the movement source. So D is supposed to make us go right. So instead of the Y and Z axis, it's gonna go towards the X axis, the positive X axis. So we gotta write it now.
The X, meaning right and left. So we can go in here and add some numbers, say 500. We'll then do 0 on the Y and 0 on the Z.
Okay, so that's X, Y, Z. It's always X, Y, Z. I gotta remember that. But yeah, 500, 0, and 0. And also, yeah, oh, we already did that. Okay, so, oopsies. Save all.
Remember to close it off with a semicolon.
Oh, yeah,
of course, we want to multiply our 500 with time.delta time.
Oh, yes.
Just like we do up here. If we now...
Yep. Okay, so also I gotta do time.delta time. Not at the end, but wherever it is, and under the comma, so like beneath, between the 500 and the comma. So times is this star, by the way. I have no idea why, but maybe X. Oh yeah, it's not X because X is the movement left and right. So the star is times. Okay, and then time dot delta time. So this will just make it so It doesn't matter how good your PC is for the frame rate and how far it goes. It just matters from last time to this time, how much.
Save this. I'll just set the forward force to something pretty low, just so our cube doesn't go flying off. We can hit play, and we should see that when we hold down D, our cube will indeed move.
Ooh. Okay, let me also set this to like 200. Wait, this is, yeah, okay. Let me set this to 200 so it doesn't go flying off. Okay, moment of truth. I also don't have any errors, so this should work. Also, it looks like it's not moving, but trust it is. See, you can kind of see it moving there. But look, it's moving. When I press D, it goes towards the x-axis, the positive x-axis. Axis. Or something like that, bro. I don't know. But yeah, if we press A or S or W, nothing really happens like that because we didn't script those yet. But this guy taught us a lot. Now I kind of just know how to do it myself. How to script the A, S, and the W. Or the W's not needed because it's already going forward. But maybe the space to make it jump. We also know how to do that. We'll just do Y, 200, force. Also, we could also maybe do crouch, which could be minus 200 on the Y. But I'm not sure how that would really work.
So we can go back and add this to the other direction as well. To do this, we
Yes.
simply copy our code, paste it right beneath.
Okay, so that's where we paste it. So you copy this. Paste it. Shut. Paste it right there. Bro. There we go. Okay, so everything's correct, right? Now let's do A. Now time dot delta. Now add force. Now it's still going to be the x-axis because it's going to go left instead of right. So instead of 500, we're going to do minus 500 to make it go left. And then times time dot delta time. And now, if my calculations are correct, it should work. Yeah! Let's go! We can go left and right. We can go left and right now. Bro, I'm such a genius. I'm such a big brain, bro.
Instead of checking for the D key, we'll check for A. And we still want to add a force on the x-axis, but we want to do so in the opposite direction. So we'll just input a minus here. Again, we can save this, play the game, and see that we can now move in both directions. In fact, why don't we go ahead and make our movement speed adjustable in the inspector the same way we did with forward force. To do that, we just add a new public float up here. And we'll call this something like sideways force. Let's
İlaçlar var. İlaçlar.
I got gummies. Yum yum yum. Bro. This gummy's eyeball is missing. And I just bit off its head. Damn.
just default that to 500. By the way, when we're dealing with float
Okay. That's smart. Mm. Mm. Mm. Mm. Mm. Mm. Mm.
Ne ki o? Ha? God mu? God. Ne demek o?
Give
Yapıyor musun? Dur. O efsane.
Tamam.
Sen bunları iç koç.
So. Cam.
Aferin sana anne. Kuzum benim.
So, like I was saying, before my mom walked into my room, so sideways force, what he did was really smart there. He could have did a public float right force and then public float left force, but he did sideways force, which covers for both of them. That is very, very smart. But that also means in the inspector, if we change one of them, that'll change both of them. I mean, that is basically what we want, but let's say you're building a more detailed game. Let's say you want left to be less force than right. Then, easy fix. I know how to do it. Yeah. This is good right now. I mean, I don't really think I'm ever gonna need to make any side other less or more than the rest. So, keep going.
Variables, you will notice me writing an F at the end of the number. This just signifies that we're talking about a float number. In some cases we can leave it out, like
Float number. It can also be a decimal.
here, but other times Unity will complain, so it's a good idea to get in the habit of just doing it every time. Again, this only applies to floats, not integers. So now we can take our sideways force and paste it instead of the 500
then
here, and
if it's an integer, it's gonna be a I guess, or nothing.
we can take our sideways force and paste it instead of the 500
Oh yeah.
here, and instead of the 500 here as well. You'll notice that it's still fine putting a minus here. When
Yeah,
we run the game, this is just going to be
minus
equal to
sideways
500, or what we said in the inspector. So let's save this, go.
So let me just take sideways force here. Now that we have that, what was it before? Okay. Instead of 500, it's gonna be sideways force times time dot delta time, and then minus sideways force, like the guy explained. Because we would just do sideways force, it's gonna also move right when we press A, but we don't want that. So now, as you might see, if we go in the Unity editor, wait for them to compile. Now here, sideways force. Very cool.
Go back into Unity and we can now see that we can adjust the sideways force as well. So let's try setting the forward force to something like 1000 and the sideways force to something like 600. And it already starts to feel like a game. If you were able to follow along with this, really good job. Programming the movement of the player is definitely not the easiest thing that you can do in Unity, and so it's always annoying that it's really the first thing that you have to do in most cases. But I hope you learned something, and remember, you don't have to understand and definitely not remember all of this the first time. I will just mention that the way that we're handling player movement here is not the...
I understand, but I don't really remember. I probably won't remember it if I'm ever making my own game. But this guy has some really, really useful tutorials that still work from over 8 years ago. This was made 8 years ago. This was made 2017. It's 2025. And it still works. That's just crazy. This guy's good. Let me subscribe to him real quick. I don't even know why I haven't already. He deserves 2 million.
the most efficient way. But no one expects you to write perfect.
Oh, also, let me just change this to 1000 like he did. Oh, my bad. There we go. Now we gotta change. You gotta make the camera follow the cube, which is gonna be really important.
Perfect code right off the bat.
And instead of doing that, an easier, like if we had obstacles here, instead of making the cube move towards them, I just think an easier way would just be to literally make the objects move towards the cube, like in Flappy Bird. The bird doesn't actually move, the pipes move towards the bird. The bird is just standing still, moving up and down. It's never actually moving on the X or Z axis. So yeah, I think we could also do that, but yeah, I mean they both work. That other way is just more efficient.
Just wanted to let you know how this could be improved. There's two main problems here. The first one is how we're getting player input. Now using input.getKey here is totally fine, and in our case it works perfectly, but as soon as we want to do stuff like smoothing player input, supporting alternative keys, or maybe even a controller, Unity has some much better ways to handle the player input. So you can definitely look into that if you want to improve it. Also, we are currently checking for input inside the fixed update. Well, it's fine in our case because what we're doing is movement, and that's usually a fairly smooth thing. It's definitely not a good idea to do for stuff like jumping or other one-off events. The reason for this is that input is updated in the update method, and if the fixed update runs slower, you might have a situation where you actually miss some player input. First, that would just mean that the input gets slightly delayed, and that's why I think it's fine here. But the recommended thing to do is check for input in the update method, then store that input in some sort of variable up here. In our case, that could just be two booleans called something like move right and move left that you'd set to true if the key is pressed and false if the key is released, and then check if those variables are true or false down here to add a force. But I really wouldn't worry too much about that right now. So that's pretty much it for this video. If you enjoyed it, make sure to subscribe so you won't miss the next one. Also, if there's anything you would really like me to include in this mini-series, definitely leave a comment and I'll see what I can do. So thanks for watching, and I will see you in the next video. Thanks to all of the awesome people who donated in January, and a special thanks to Derek Heemskirk, Faisal Marify, James Calhoun, Robert Bonham, Peter Locke, and Jason. In this video, we'll have a look at making our camera follow the movement of our player.
like
Not really
this.
much to say about that, let's just jump into it. So as with everything else in game development, making the camera follow the player can be done in multiple ways. The first and most obvious one is probably just parenting the camera to the player. Unity allows us to nest game objects. That means that we can take our camera here selected and drag it under our player. We have now parented our main camera to our player, and the main camera is now a child of that player. This means that whenever we go and move our player, the camera is going to move with him. However,
Okay, 32-second tutorial. Next. I'm kidding. Maybe he'll say something. But let me just go and do that real quick. Now let's see. Yep, it literally works. I did not do a single thing.
the problem with this is that if we go ahead and rotate our player, the camera also rotates with them. And that's going to look very weird when we collide with something and the cube starts spinning,
That's true,
then the
that's
camera is going to spin with it and everything's going to be confusing.
Would
So what
look
we do
more
instead
realistic,
is we
but
take our
yeah.
camera and unparent it, and we make it follow only the position of our player using a script. So let's go and hit add component. We'll call it something like follow player. Select C# and hit create an add. Let's double click it to open it up in Visual Studio. And let's double click it to open it up in Visual Studio.
Oh, you can change the language? Oh, well, not anymore.
And let's clean up the script a bit. So let's delete the two using tags up here, and let's also delete the start method. Not just
Bro,
like
slow
the
down,
bit. So
buddy.
let's delete the two using tags up here, and let's also delete the start method. Not just
Alright. I bet. Uh-oh, SpaghettiOs.
just like when we wanted to move our player, where we wanted to move him a tiny bit each frame, we also want to have our camera snap to the position of our player each frame. So we'll put our code inside of the update method. However, in order to set our camera's position to that of the player, we need a reference to the player. The easiest way to do this is by making a variable that stores the reference to our player. So when we create a variable, we write public, and so far we've only looked at the basic data types, stuff like float, integer, and string, that stores numbers and text. But variables can actually also store way more complicated. To set our camera's position to that of the player, we need a reference to the player. The easiest way to do this is by making a variable that stores the reference to our player. So when we create a variable, we write public, and so far we've only looked at the basic data types, stuff like float, integer, and string, that stores numbers and text. But variables can actually also store way more complicated stuff. If we go ahead and write transform here, we can basically get a link to our player with information about his position, rotation, and scale. Remember, the component responsible for these things are indeed called a transform. So that's what we're getting a reference to. Then of course we need to name it something, but we'll just name it player. Let's close that with a semicolon, and if we just try and hit save now and head back into Unity, we see that an empty slot called player now appears. All we need to do now to make this player variable point to our specific player is to take the player and drag him into that slot. So now every time we write player in our code, it refers to that object. To test this, we can go inside of our update and we can try displaying the position of our player in the...
Calm down, buddy. Calm down. Alright, perfect.
The console. To do that, we write debug.log to write a message to the console.
Okay, void update and then debug.log. And we're gonna write a message here. Where's my colon? Or colon, I don't know.